Alright, hi guys. Thanks for tuning in today's video from my YouTube channel, That ABA Guy, a channel dedicated to the dissemination and education on the field of applied behavior analysis. In today's video, we will be discussing what science is and the philosophical underpinnings of what science is composed of and how it relates to the science of ABA. So in today's video, the content that we'll be touching on in terms of the BACB 5th edition task list are the goals of ABA as a science, which include description, prediction, and control, as well as what we discuss in the philosophical assumptions that underline the field and science of ABA, which include some things such as determinism, empiricism, parsimony, and pragmatism. All right, so we're going to start with a general overview of what constitutes a science. Science is commonly known as a structured approach towards gathering information about the world phenomenons in order to gain a greater understanding of those phenomenons of interest. Therefore, science is generally applied to specific topics or phenomenons dependent on a researcher's field of study. For instance, in regards to the field of ABA, researchers are generally interested in studying the phenomenon of socially significant behavior, such as what environmental factors affect such behavior and how we can intervene to change that behavior of interest. So when we talk about science and our understanding of science, there are three levels of scientific knowledge. These three levels consist of descriptive knowledge, prediction knowledge, and knowledge of control. These levels increase in the amount of knowledge they provide an individual regarding a specific phenomenon, with control being the highest level of scientific knowledge. The first level of scientific knowledge is descriptive knowledge, which is the gathering of and recording of facts and characteristics regarding a phenomenon of interest. For example, if a researcher was interested in studying the hunting behavior and patterns of a lion, they could conduct observations and keep a recording of what the lion does during the lead up to attacking a prey. This would resemble descriptive knowledge because the researcher would be acquiring what lion hunting looks like and what the characteristics of lion hunting are. Generally, when scientists acquire descriptive knowledge, this allows them to form hypotheses as well as research questions for further testing within their research projects. The second level of scientific knowledge is predictive knowledge, which is when a researcher is making a considerable amount of observations in order to witness a consistent covariation between observed events and variables. For example, if someone did many observations of a dog drinking water outside and noticed that when it was hotter outside, the more water the dog drank, this would constitute predictive knowledge because the observer consistently saw this observation and therefore led to this consistent notice that the hotter it was outside, the more water the dog drank. Therefore, a common type of predictive knowledge in science is correlations between variables that researchers may identify through repeated observations and noticing consistent fluctuations within one variable and another. The last level and the highest level of scientific knowledge, as previously said, is the knowledge of control. Control is when a researcher is able to test and assess whether a functional relation exists between two variables. In other words, they can test whether a change in one variable can conclusively say that is a cause for the change in another variable of interest. And so the knowledge of control is generally demonstrated through the execution of a scientific experimentation in which variables are manipulated to assess for their effects on the other variables of interest and to determine that the manipulation of that variable was truly the cause for the change in the other variable. All right. Now that we have gone through an overview of what science is and the types of knowledge that compose scientific knowledge, we are now going to go through some of the approaches philosophers and researchers take towards science. So first we're going to talk about determinism, which says that we exist in a lawful universe and that things occur as the result of other events. An example would be that the event of the polar regions on Earth melting is happening because of the event of global warming taking place. In other words, this is representative determinism because we are saying that the polar ice caps are melting because of the event of global warming, not just because willy-nilly melting or without a specific cause. An ABA example would be that a student pushes the homework materials due to the event of the teacher placing demand on the student. So why did the student push the homework materials? Because of the lawful result of the event of the teacher placing demand on the student beforehand. Next, we're going to talk about accidentalism, which is the idea that events in the universe occur by accident without any cause. An ABA example would be that a student randomly throws a desk across the classroom without any event, just willy-nilly and randomly. And we can say the same about the polar ice cap example, as I said earlier, in which the polar regions are melting without any cause or antecedent beforehand. And touch on fatalism real quick. Fatalism is the idea that events in the universe occur due to predetermined elements or fate. So not necessarily random, but in a sense that there's like this innate or higher being that is determining when an event happens, not because necessarily of the causal relation of other events that may occur before that event in the universe, which determinism states is their approach to the cause of behavior. Fate is more that like a higher being, such as if someone is religious, so it's say maybe God's plan is to have this behavior occur. Next, we have empiricism, which is an approach to science in which researchers use objective procedures in order to study a phenomenon of interest in order to quantify that phenomenon for further analysis. This would include using operational definitions and using systematic data collection systems during experiments in order to obtain data without the influence of subjective beliefs influencing that data results. This can be shown in ABA when we have, maybe multiple observers observing a behavior, and when we write clear operational definitions of behavior to ensure that we maybe code in or click in for same instances of behavior without much or with as little subjective variability in terms of observation as much as possible. And some examples of empiricism might be employed are experimentation, replication. We've already talked about experimentation, but so I'll go mostly talking about replication, which is basically the repetition or repeating of experiments in order to verify the findings of prior runs of that experiment and to ensure the reliability of prior findings. So this next approach is called parsimony, which describes how individuals should go through all the simple explanations for a phenomenon before resorting to more complex explanations for why that phenomenon occurred. An ABA example would be ruling out that a student's crying is due to them being hungry for a snack before considering the cause to be due to the, let's say, child imitating a character from a show they watched a week ago. And I know this is kind of a silly example, but I guess what I'm trying to get at is that maybe, let's say you knew that that child didn't have breakfast that morning and they're crying. It would be more simple to see, well, are they crying because they didn't have breakfast and are therefore hungry? That'd be the most likely or simple explanation. But, maybe in the back of your mind, you're thinking, well, we know they were watching the show that they really liked a week ago where the child was crying, and I think they're crying in a similar manner. Um, you would want to rule out the most simple and likely explanation because an antecedent that occurred that day is generally might be more likely to have caused behavior, especially if there's a history of them crying after being hungry, compared to assuming the cause may be from watching a show and by chance imitating that crying in the show a week ago before the behavior, which is a much more earlier antecedent compared to the no eating, not having breakfast. All right, and the last approach we're going to talk about is philosophical doubt, which is the idea that scholars should continually be questionable of what is regarded as true in order to verify published findings and attest whether scientific findings are actually true or valid. And this is important because this ensures that pseudoscience does not contaminate the field and that we thoroughly vet through new research when it's published. And basically, this idea is that you shouldn't just accept something that's true just because you hear it from another person or just because maybe you respect the authority of the other person. It means that you would want to go through the data yourself, research, look over their methods, maybe do some even research or replication of yourself to verify that it is true. You basically just don't want to take anyone's word for it because this can be dangerous in the science, in which, by doing so gives birth to pseudoscientific practices if everyone just believed everything that an authority figure might say without thoroughly vetting through the data to back it up. Okay, so this is a pretty short video, and here are the references that were used to make this presentation. As you can see, I heavily rely on Cooper. It's a really good book for anyone who's studying for the BSCB exam. But yeah, so thanks for tuning in again to this video. I hope you found it helpful, and comment and subscribe, and let me know if there's any kind of topics you want me to touch on or go in depth about in future videos. But yeah, thanks again, and I'll see you all soon.